Okay, dear students, in the last video we have discussed about the relation between focal length and radius of curvature of a spherical mirror. Today we are going to discuss about what the mirror formula. This is the very next topic of what the relation between f and r. What is f? F is the focal length of a spherical mirror, you know, is it not? And what was r? R is the radius of curvature. Of the spherical mirror. We have the relation between what f and r. In the last video we have discussed about this, and the relation between these two was what? F equal to r by 2. That means when you divide radius of curvature by 2, you get the what? Focal length of the spherical mirror. Whether it is a convex mirror or a concave mirror, both are spherical mirrors, so relation is same, and the relation is this one, f equal to r by 2. Now we are going to discuss about what? The mirror formula. Okay, so note it down, mirror formula. But you know there are two types of mirrors, concave and convex. So let us first discuss about the concave mirror. That means we are going to have to find the relation for mirror formula using a concave mirror. Okay, so let us suppose this is a concave mirror XY. Is it? This is a concave mirror XY. The midpoint is always called the pole of the mirror, you know. Draw this axis. This is called what? The principal axis. Do you remember this one? This is the principal axis because this pass through what? The pole of the mirror. Midpoint of the mirror is called pole of the mirror. This is the principal axis, as it is normal to the mirror and passing through what? The pole. That is why it is the principal axis. Okay. Suppose this is focus. This is the focus of the mirror. Okay. This is suppose the center of curvature of the mirror. C is what? The center of curvature. That means if you complete this surface, it becomes a what? Sphere. Center of that sphere is called what? The center of curvature of the mirror. Let us suppose that there is an object AB which is placed in front of the mirror. Object AB is a linear object which is placed in front of the mirror laterally. Okay. Now this is a ray parallel to principal axis. The ray which is incident on the mirror and parallel to principal axis, after reflection must pass through what? The focus of the mirror. Clear? As the incident ray is parallel to the principal axis, that is why after reflection the reflected ray must go through what? The focus. Next, let us consider another ray which is incident on the pole of the mirror. After reflection, because this is the normal, so this is angle of incidence. So according to law of reflection, this is what? The reflected ray. This angle and this angle must be equal because this is angle of incidence, this is angle of reflection. Okay. Now this is the reflected ray from this one, this is the reflected ray from this one. Now two reflected rays meet at this point, and the point at which the two reflected rays meet, okay, is the position of the image. Suppose this is the image A dash B dash. The image so formed is what? A real image. The image formed is real image because the reflected rays physically meet at a point A dash. When the reflected rays physically meet, then the image formed is what? The real. This image is real because the two reflected rays physically meet at the point A dash. Okay, but the image is not erect, it is inverted because this is below principal axis and the object is what? Above principal axis. The object is above principal axis and the image is below principal axis. That is why the image so formed is what? Inverted. Okay, again one more important thing here is that as the object is beyond center of curvature, so the image A dash B dash must be between what? C and F. So in case of a concave mirror, when the object is beyond center of curvature, then the image is always formed between what? C and F. Okay, now next, all distances should be measured from what? The pole of the mirror. Do you remember this one? All distances should be made from pole of the mirror. So distance of focus from the pole of the mirror is f. This is called what? The focal length, you know. Distance of object AB from pole of the mirror is denoted by u, and this is called what? The object distance. Clear? Distance of object is always denoted by u. All distances should be measured from pole of the mirror. Distance of focus is called focal length. Distance of object is called u, and the distance of image a dash b dash from the position of pole is denoted by v, and this is called what? The image distance. Now, if we find a relation between focal length, object distance, and image distance, that will be the mirror formula. That will be the mirror formula. Okay, so what is a mirror formula? A mirror formula is a relation between focal length, object distance, and image distance of a spherical mirror. Okay, let us suppose this is figure 1. Okay, this point is suppose K. Now, write a line, the ray diagram, how a real image is formed, the ray diagram how a real image is formed by a concave mirror is shown in figure 1. Okay, so in support of this figure, just write a line, a ray diagram how a real image is formed by a concave mirror is shown in figure 1. Okay, now let us look at the figure. Look at the figure. Here you see there are two triangles which are similar. Triangle ABP and triangle A dash B dash P. These are two similar triangles. You see triangle ABP and A dash B dash P. These two triangles are similar. In figure, triangles ABP and A dash B dash P are similar. So A dash B dash divided by AB, is it not? A dash B dash divided by AB. This is the vertical side. This is again a vertical side or another triangle. So vertical side divided by vertical side. A dash B dash by AB equal to horizontal side divided by horizontal side. So equal to PB dash equal to PB dash divided by PB. Am I right? These two triangles are similar. That is why vertical side by vertical side, A dash B dash by AB equal to what? PB dash by PB. Okay, so for two similar triangles, just divide vertical side by vertical side and horizontal side by horizontal side. Okay, so let us suppose this is equation number 1. Again, you see another two triangles are similar. Another two triangles in the figure, another two triangles are similar. One is KPF and other is what? A dash B dash F. Let us suppose that point K is close to P, then you can consider KP as a straight line. If point K is close to P, if you suppose that the point K is close to P, then you can take KP as a straight line. In that case, triangle KPF and A dash B dash F are similar triangles. These two triangles are similar. Well, again, triangles KPF and A dash B dash F are similar. Is it? So use the same principle. Vertical side by vertical side, that means what? A dash B dash by KP. A dash B dash by KP equal to what? B dash F by PF. Is it? B dash F by PF. But in figure, because this ray is parallel to principal axis, so height of KP is equal to height of AB. So in place of KP, you can write AB, right? So A dash B dash divided by, in place of KP write AB, because height of KP is equal to what? AB. Okay, equal to B dash F divided by PF. Let it be equation number 2. Okay, now in equation 1 and 2, these two sides are equal, left hand sides are equal, so you can equate the right hand sides also. Because left hand sides are equal, so right hand sides must be equal. Because you know, if x equal to y and x equal to z, that means y equal to z. Clear? So equating equations 1 and 2, we get from 1 and 2. From equations 1 and 2, we can write, just equate the right hand sides because left hand sides are equal. So what? PB dash by PB equal to B dash F by PF. PB dash by PB, PB dash by PB equal to B dash F by PF. Okay. Now you can write B dash F. Just look at the figure. B dash F can be written as what? PB dash minus PF. Is it? PB dash minus PF. Is it not? B dash F. B dash F can be written as what? PB dash minus PF. When you subtract PF from PB dash, then you get B dash F. So in place of B dash F, write PB dash minus PF. This is because distances are measured from pole. Okay, here there is P, here there is P, here also P, but there is no P here. Okay, so in place of B dash F, once you write PB dash minus PF, so P comes. Okay, distances are measured from pole, so P must be there to give U, V or F. Clear? So this is PF. Now from figure, what is PB dash equal to? PB dash means V, image distance. What is PB? PB means object distance U, right? What is PB dash? V. What is PF? PF means distance of focus from pole, this focal length. F divided by PF means F. Okay. Right? Now use sign conventions. As I have told you earlier, U, V and F are all negative. In the last video, I have discussed about what? We have discussed about the sign conventions. If distances are measured from pole, if a particular length or distance is in front of the mirror, it is taken as negative. If a particular length is behind the mirror, it is taken as positive. Here in this figure, U, V and F all are in front of the mirror. That is why U, V and F all are negative. No length is behind the mirror. All the lengths measured from pole are in front of the mirror. That is why you can take U, V, F all negative. So all are negative according to sign convention. Clear? Okay. So I can now erase this figure. So we are using sign conventions, and in the figure you see all are negative because all are in front of the mirror. So now you can write it like this: minus minus cancel, V by U equal to minus V, minus minus plus F divided by minus F. So use cross multiplication. Minus VF equal to minus UV plus UF. Okay, so you can write it like this: UV equal to UF plus VF. Am I right? This was minus UV, so it is plus UV. This is minus. If you this is minus, so if you take this in the right hand side, then it becomes positive. Okay, so divide whole equation throughout by UVF. Dividing throughout by U into V into F, we get. Divide the whole equation by UVF. Each and every term should be divided by this product UVF. So you get UV by UVF equal to UF by UVF plus VF by UVF. So UV cancel, UF cancel, VF cancel. So you get it 1 by F equal to 1 by V plus 1 by U. Right? This is what? This is the final relation between object distance U, image distance V and focal length F of the mirror, and this is called the mirror formula. So what is mirror formula? Relation between U, V and F. What is U? Object distance. What is V? Image distance. What is F? Focal length of the spherical mirror. This is the mirror formula. This is the mirror formula. So this is the mirror formula, and mirror formula is same for all kind of spherical mirrors, because there are two spherical mirrors, you know. One is concave mirror, other is convex mirror. So this mirror formula is, so this is the mirror formula, and this is for both what kind of spherical mirrors, concave mirror and convex mirror. But in the next video we will derive the same relation for convex mirror. Relation will be same because this is the mirror formula for spherical mirror, not for only concave mirror or convex mirror, because concave and convex both are spherical mirrors. So this is the mirror formula for spherical mirror. So if we will derive a relation for convex mirror, same will be the relation, because convex mirror is again a kind of spherical mirror. Okay, thank you.